1 million views. That video of me assembling my solar generator got 1 million views on YouTube. You know, that just flat out amazes me. I'm not a professional or anything. I'm just your average typical guy doing this for fun. I just built this for fun. You know, I'm not here to sell you guys anything. I just thought, hey, this looks like a fun thing to build. And I had a friend who had been asking quite a few questions about one he was trying to build. So that's kind of how this whole project came to light in the first place. You know, when I had uploaded it, I didn't think it was going to get more than 1,000, 2,000, maybe 3,000 views at best. And then a couple days went by and I guess YouTube started promoting it. Based on whatever algorithm they have, we'll never know and never understand how that quite works. But I genuinely do appreciate everybody who watched the video and had taken the time to comment, provide input, ideas, suggestions, and just general feedback. And one of the most common things that was said was not to worry about the length. Like I had said in the original video, it was 33 minutes long, and I thought that was kind of long, but after reading what some of you guys had said, I fully understand the fact that I had trimmed it down to just the information on the build itself, and I didn't have any fluff or anything like that. And when I think back about the types of videos I watch and the ones that I get bored while I'm watching them, they typically are ones that are just drawn out and don't have a lot of actual useful content to them. One piece of criticism that was received quite a bit was, I guess a lot of people didn't like that I had called this a solar generator. You know, I do tend to agree that it's not a generator in the conventional sense, that is, there is no, you know, gasoline or diesel engine that's turning a generator or an alternator or anything like that, but that's what this device is called. This device is called a solar generator. I am not the one personally who invented that term. You know, if you go on Amazon, you'll find hundreds of them. If you go on Google, there's thousands of solar generators out there. And yes, it is just a battery pack and an inverter in a box. A few other questions that were asked. The completed build weighs 57 pounds. I don't know off the top of my head what that is in kilograms. And yes, I can provide a wiring diagram. However, I am not a graphics artist, so it's pretty much just going to be lines on an image. If you want to see that, there will be a link in the description down below where you can find that diagram. But I do think you'll get a lot more out of watching the video in the wiring explanation towards the end versus looking at the actual diagram. There were a couple people who asked why I had my clamp meter on the AC amps setting instead of the DC amps setting when I was measuring DC amps. When I used this clamp meter, I was not measuring actual amps. I was measuring the inrush current. Now, yes, that is measured in amps, but inrush current is different than measuring, you know, the continuous current of your circuit. The manual for this particular meter says that when you're measuring inrush current, whether it's AC or DC, the meter needs to be put on the AC amps setting, and then you need to push the select button until you get inrush mode. And you'll know it's in inrush mode based on the inrush logo lighting up on the display. Even though the dial is on AC amps, it is still measuring both AC or DC in inrush mode. Several people asked why I didn't use a car battery. Car batteries are designed to produce a large amount of current in a very short time span to start your engine. They are not designed to deep cycle to constantly charge and discharge. Yes, a car battery will work for a solar generator, but it's not going to last as long. You'll find after a few months the battery is severely deteriorated if you're continuously doing full cycles, full charge and discharge of the battery. Additionally, they're expensive, they're very heavy, and with flooded batteries you have to worry about the hydrogen gas they produce while you're charging. Yes, there are sealed lead-acid batteries as well, such as those used in UPSs and battery backups. Those will work, but again, they're pricey and they're not going to last nearly as long as these lithium batteries would. How many cycles can I get out of it? That's a very tough question to ask because when the manufacturer tests their cells, they measure cycles based on 0% charge all the way up to 100% charge and then back down to 0% charge. That's one full cycle. And they generally rate those around 400, to 800 to 1200, somewhere in that typical range. The difference is when you're using something like this, you're not doing full charge and discharge cycles. So your battery is going to last a heck of a lot longer. It's going to get a lot more cycles versus if you were doing full charge all the way down to zero charge. Additionally, once you reach that rating of the amount of cycles, that doesn't mean your battery is completely dead. It typically means the battery is only going to have a 60 or 70% of the original rated capacity. The battery is still going to work just fine. It's still going to produce power. It's just not going to have the 100% rated capacity as when it was brand new. So as far as how many cycles I'm going to get out of this, that is a very difficult question to answer. A lot of people ask if I can build them one or if they can buy this one or if I plan to sell these. And the answer is no, unfortunately. And the big reason for that is simply liability. If I were to sell this to somebody and it caught fire in their house, obviously that would be on me as the person who built and sold this product. So when you go out and manufacture a product, you're assuming the liability for that product. And that's one reason the units available on the market are so expensive, is because that manufacturer is likely paying liability insurance, and a small cost of each inverter is going to pay that liability insurance. So while I would love to build several of these and sell them, again, just for fun, make a few bucks on the side, it's just not going to happen. Many people noticed the one cell that was installed backwards. Yes, I did fix the cell that was installed backwards. That had happened when I went to pick up the battery pack and you saw the lid fall off, and I had to take out half of the cells and put them back in, and that one cell was unintentionally reversed. I did catch and fix that when I got to the spot welding step. I'm actually impressed at how many people caught on to that. There had to be 100 or 200 people that pointed that out. An interesting aspect is there was another mistake and only one person caught on to that. When I showed the completed spot welded pack, there was one cell that I had actually missed spot welding, and only one person pointed it out. So unfortunately, at some point, I have to take the entire thing apart and fix that spot weld, because there is a cell in there that is not spot welded. And I just kind of find it ironic how many hundreds of people pointed out the cell that was backwards, and only one person pointed out the cell that was not spot welded. And thank you for pointing it out, because I had completely missed that and wasn't aware either. A lot of people also pointed out that the batteries are out of stock on Battery Hookup's website. Yes, they are, and unfortunately, I haven't seen any restocked. They do have other batteries for sale that are 2200 milliamp hours or 2400 milliamp hours. I would keep checking back, because they are a battery recycling facility. They are not selling new batteries. It's only going to be the inventory they get in for recycling. And they definitely are a quality distributor in the United States. It's not a scam site, as some people said it's a scam site. I've personally purchased many orders from them. So definitely keep checking back. Maybe he'll get them in stock again soon. Unfortunately, I don't have any more information on that. But if you do decide to purchase something from their website, if you use the code BATTERY, that'll give you an additional 10% off your order. So it definitely brings down the price a little bit from what's posted on the website. A lot of people asked how long the battery will last in terms of, how long can I power my fridge with it? How long can I watch TV with it? And again, that's a very difficult question to answer. You need to calculate that out based on your load. So this stores 3.5 kilowatt hours of power. So that means if you had a standard 100 watt incandescent light bulb, this would power that bulb for 35 hours. Now also, you have to assume there is quite a bit of efficiency loss in the inverter conversion from DC to AC. So that inverter may only be about 80 to 85% efficient. As far as loads that turn on and off, like if you were powering a refrigerator with this and you wanted to know how long can I run my refrigerator, well, the refrigerator compressor only turns on once or twice an hour, and as long as you're not opening and closing the doors. So for what I would recommend to test that is to pick up one of these kilowatt meters. You can get them on Amazon. They're about 15 or 20 bucks. And you would plug your appliance into here, and then you'd plug this into your outlet. And I would just let your refrigerator run for about 24 hours, and this will tell you how much power it consumed in kilowatt hours. So if this said you used 2 kilowatt hours in the 24-hour period of your refrigerator, you can divide the 2 by 24 hours, since that was a measurement over 24 hours, and that'll tell you how many kilowatt hours it used in 1 hour. You would then take your battery, this is 3.5 kilowatt hours. I would multiply that by 0.8 to account for the efficiency. So you have 3.5 times 0.8, and then take that number and divide it by the calculation you got from this meter, and that will give you a very good estimate on how long this will last with the device you're trying to power. I'll leave a link to where you can buy these as well in the description below if you're interested. There's also quite a few ideas in terms of upgrades and why I did what I did and ways I could do it better. And those are especially the comments I really appreciate, because it typically gets your mind thinking of things you hadn't thought about otherwise, and you're thinking, oh yeah, I could have done it that way, or what if I did do it that way, or maybe I should go back and fix it. Some of the things that were recommended were to install a screen on the fan to prevent it from pulling in dust and bugs and all kind of things like that. I wasn't really sure what to use, because I didn't want it to be too restrictive, since these are just computer case fans. They're not really moving a lot of air. So for the time being, I ended up just putting a small square of a dryer sheet in there. And that actually works as quite a good filter. It lets a great amount of air through, and it also prevents the dust and bugs and stuff from getting in. Another big thing that was mentioned was the temperature sensor. I originally had it on this side measuring the intake air temperature, and quite a few people pointed out that it would be better to have it on the output side, where you'd be measuring the exhaust air from the inverter. And yes, that absolutely was a good idea, and that was a mistake on my part. I was thinking a little backwards, thinking it'd be measuring the air over here. I have since moved it up into the top left corner, so when I close this lid, it's going directly in front of the fan, and it is measuring the temperature on the output of the inverter, which is when you would want your fans on to push that air out of the enclosure. There's somebody out there who asked if this would run an air conditioner, and I don't know, but that does sound like a fun test. I haven't tried this yet. So we've got ourselves an air conditioner. This is a Hair brand air conditioner. It's a 5,000 watt BTU, and it's rated for 445 watts at 3.9 amps. Just plug it in over here, turn it on. So yes, it does power an air conditioner, and quite well as a matter of fact. So over here we can see we're pulling 7.1 amps from the battery, 392 watts, so that's pretty close to the rating on the air conditioner itself. So yeah, that's about it. Just want to say thank you again to everybody who made this happen. I never thought I was going to get anywhere near 1 million views on a YouTube video, so that feels really great. The next several videos you'll see me put out will be on my shipping container project. For those of you who are new to the channel, because there are quite a few, 10, 20,000 new subscribers, I think, somewhere in that ballpark, I'm working on building an off-grid storage system in a Charleston Marine shipping container. So that's going to be an ongoing project for the next month or two. Once that's completed, I will hopefully get back to doing some more of the smaller builds that I know you guys are most interested in seeing, and also that I have the most fun doing as well. And don't forget to hit that like button down below, and I'll see you in the next one.